In this video, we will use thermodynamics to predict whether a reaction occurs or not. Delta G, or the change in free energy, is the thermodynamic quantity which we'll use to make that prediction. If delta G is less than 0, that means the reaction occurs spontaneously. Note that two factors, enthalpy and entropy, determine whether a reaction occurs spontaneously. We can also relate delta G to the equilibrium constant. If KEQ is large, that is, a lot of products form, that means delta G should be less than 0 and the reaction occurs spontaneously. To help us predict whether a reaction occurs, we want to identify what type of energy is contained in matter. So stop the video and see if you can answer these questions. We will answer each question during the video. A rock and gold cup do not contain heat nor work, but each substance does contain internal energy and enthalpy. The energy contained in a substance are called thermodynamic quantities, but they cannot be directly measured. A substance does not contain heat or work. Those are non-thermodynamic quantities. But we can directly measure those non-thermodynamic quantities, heat and work. Not only are internal energy and enthalpy thermodynamic quantities, so are entropy and free energy. These quantities cannot be directly measured. Heat and work are non-thermodynamic quantities, and here are the equations which we can use to directly measure heat and work. So by measuring heat and work and relating heat and work to thermodynamic quantities, we can quantify those thermodynamic quantities: internal energy, enthalpy, entropy, and free energy. This cartoon describes what internal energy is, so stop the video and read the cartoon. We know heat is the energy transferred between two objects due to a difference in temperature. When a hot object comes in contact with a cold object, some of the internal energy is converted into enthalpy, which is converted into heat. So this equation relates the thermodynamic quantity, enthalpy, to the non-thermodynamic quantity, heat, which we can measure. So for the question earlier in the video, most reactions are exothermic. So substances such as the gold cup do not contain heat, but they do contain internal energy. So when a hot object comes in contact with a cold object, some of that internal energy is converted into enthalpy, and then that enthalpy is converted into heat. That heat is transferred from the hot object to the cold object. So in this cartoon, note that the hot object and the cold object contain internal energy. So when your hot hand touches another person's cold hand, some of that internal energy is converted into enthalpy, which is transferred to the other person as heat. Enthalpy and entropy are related to free energy, delta G. So enthalpy and entropy are the thermodynamic quantities, which are the two driving forces that determines whether a reaction occurs spontaneously. One way to define entropy is the amount of disorder or order in a system. So this equation relates entropy, a thermodynamic quantity, to heat, a non-thermodynamic quantity that we can measure. You may have encountered this situation before, so stop the video and identify the direction for which delta S is greater than 0. So here is the answer. Note that the ordered room has a lower entropy than the disordered room. So delta S is greater than 0 going from the ordered room to the disordered room. To organize your disordered room to an ordered room, delta S is going to be less than 0. Another way to look at entropy is the dispersal of energy. So in nature, things wouldn't be at a low energy, but it takes energy to keep things ordered. So stop the video and fill in this blank. So the answer is increasing. So when you can't hold back the door, all your stuff is dispersed, so the entropy is increasing. So let's see what's happening here. Stop the video and answer those two questions. The answer is yes, the energy of the air inside the balloon is being dispersed or spread out to its surroundings. That means delta S is going to be greater than 0. Let's compare the entropy of different states of matter. So stop the video and answer this question, and then figure out whether delta S is greater than 0, less than 0, equal to 0, for this phase change. So I'm pretty sure you answered that a gas has the highest entropy, and delta S is greater than 0 when a solid melts. So here are the answers to 2 questions from earlier in the video. So let's apply what we know about entropy to chemical reactions. So stop the video and answer this question for these 2 reactions. So the answers are delta S is going to be greater than 0 when a liquid evaporates. For the second reaction, note, there are more moles of products than a reactant, so we would predict that delta S for that reaction should also be greater than 0. We want to use thermodynamics to predict whether a reaction occurs, that is, whether it's spontaneous. So stop the video and identify which process is spontaneous. So the answer is B. Note that that rock spontaneously rolls down the hill. Now these are reactions you've seen before, so stop the video and identify which reaction occurs spontaneously. So here are the answers. When we add salt to water, the salt dissolves by itself, so that's a spontaneous reaction. Water does not boil all by itself, so that's not a spontaneous reaction. We have to supply energy to make water boil. Burning wood is spontaneous. Once the reactants overcome the activation energy and gets the reaction started, it'll burn until all the reactants are gone. Photosynthesis is sort of the reverse of burning wood, so if burning wood is spontaneous, the reverse reaction is not spontaneous. Delta G, or the change in free energy, is the thermodynamic quantity which we use to predict whether a reaction occurs spontaneously or not. So if delta G is greater than 0, the reaction is not spontaneous. If it's less than 0, it is spontaneous. Free energy is like extra energy, so if that extra energy was lost going from reactants to products, that reaction occurs spontaneously. On the other hand, if the products have more extra energy or free energy than the reactants, that means extra energy had to be put into the system. That reaction would not be spontaneous. In other words, the reaction does not occur. In part 2 of this video, we're going to see how enthalpy and entropy help or not help make a reaction occur.